Hello everyone. In this video, we're going to be solving this logarithmic equation for x. We have ln of the square root of 1 plus x squared plus x equals y. And we're going to be solving for x in this equation. Great, I'll be presenting two methods, and let's start with the first method. So, for our first method, we're going to use the fact that e to the power ln something equals something. So I can safely say that e to the power ln, z equals z. Obviously, z needs to be greater than 0. The logarithmic function needs to be well-defined, so on and so forth. So those conditions need to be satisfied by x, but we don't have to worry about it right now. So let's go ahead and do e to the power both sides. So we're going to get e to the power ln square root of 1 plus x squared plus x equals e to the power y. And e to the power ln, that thing is going to be equal to square root of 1 plus x squared plus x. So we get an equation from here, and normally when you get an equation like this, and let's say you're trying to solve for x, you could have a numerical value on the right hand side. You would probably get rid of the radical. But before we square both sides, let's go ahead and put the x on the right hand side so we don't introduce more radical terms. So I'm going to square both sides, but first I will isolate the radical. And then now let's go ahead and square both sides. I'm going to square this and that. Square root of 1 plus x squared is going to be 1 plus x squared. And this is like a minus b quantity squared, so it's going to be e to the power 2y minus 2e to the power y times x plus x squared. The good thing about this equation is that x squared cancels out, leaving us with a first degree or first power of x, which is good because we're trying to solve for x, remember? So let's go ahead and put that on the left hand side so it becomes positive. That's what I usually do first. And then bring the 1 over to the right by subtracting 1 from both sides, and we get the following. Great. Now our goal is to solve for x, so let's go ahead and divide both sides by 2 times e to the power y. So from here we can find the x value basically. So x becomes e to the power 2y minus 1 divided by 2e to the power y. Great. So we were able to solve for x, and obviously x is in terms of y. And that brings us to the end of the first method. Now let's go ahead and talk about the second method. Obviously our second method is different. It definitely contains a different approach. So first of all, let's start here. We do know that square root of 1 plus x squared, we already know that square root of 1 plus x squared plus x is equal to e to the power y. And again, our goal is to solve for x, but we're not going to use the first method here. So can we approach this problem differently? So consider the following. 1 over square root of 1 plus x squared plus x. Now, what am I trying to do here? Like, why am I interested in the reciprocal of this term? Because it contains a radical. Now, we're going to rationalize the denominator. So let's go ahead and rationalize the denominator. And something interesting is going to happen here. The numerator is going to be 1 times that, so we get square root of 1 plus x squared minus x divided by, so from difference of two squares, when you multiply two conjugates, you get a squared minus b squared, so it becomes 1 plus x squared minus x squared. Bingo. That is 1, so we can go ahead and simplify that. Let's go ahead and simplify this. X squared cancels out, and we end up with square root of 1 plus x squared minus x. Now, we started off with something that equals e to the power y, and then we considered the reciprocal of that expression. So since that expression originally equals e to the power y, this is going to equal the reciprocal of e to the power y, which is 1 over e to the power y, and that can be written as e to the power negative y. So remember, this is the original expression, and then we are considering the reciprocal of that, which becomes e to the power negative y. Great. At this point, we can go ahead and set up a system and solve for x that way. So that's what makes this approach different from the first one. Okay, that's what's really cool about it. So let me rewrite my first fact. Square root of 1 plus x squared, what was that? Plus x equals e to the power y. That was my first expression. Remember, I got that with the first method. I didn't do it again, but consider the fact here, like we just e to the power, both sides, whatever you want to call that, and we got that equation. Okay, great. So that comes from the first method, and we have another equation from the reciprocal, and that is square root of, sometimes this happens with notability. Anyways, square root of 1 plus x squared minus x equals e to the power negative. I wish there was a way to kind of freeze the screen so it doesn't like zoom in and zoom out when you touch it. Anyways, so this is my system of equations, and I'm going to solve this system. My goal is to find x. Remember, so think about it for a minute. So how would you solve for x? Well, I can go ahead and add both of these equations. That's definitely a method. So let's go ahead and consider that first. Obviously, that's not a good way to approach it in my opinion, but let's just do it for fun. If you add these two equations, you're going to get 2 times the square root of 1 plus x squared. And on the right-hand side, you're going to get e to the power y plus e to the power negative y. And then you can go ahead and divide both sides by 2. And then that's going to give you a radical. Now, we want to solve for x, so let's go ahead and square both sides. So you can consider this like a 2a, method 2, maybe branch a. And this becomes something squared, right? So we're not going to get into that right now, but you get the idea. And then my next step would be subtracting 1 from both sides. Obviously, this is not better than the 2b, or not 2b, right? Great. So x squared, and then you're going to square root both sides. Obviously, you got to do some work here with the manipulation, so on and so forth, right? I mean, you can square both sides. You can also make a common denominator if you want. You can write e to the power negative y as 1 over e to the power y, and then do the squaring, or you can just square as is, and then at the end, you're going to need to square root both sides because your goal is to solve for x. And obviously, at that point, you have to consider the domain and range, like x's can be on this interval, so on and so forth. Anyways, let me just show you what 2b looks like because 2b or not 2b, right? Okay, great. So let's go ahead and take a look at it from a different approach. I'm going to go ahead and erase this because this is not good. I mean, it's a method, but it's just longer. Anyways, so now I'm going to subtract. Instead of adding, I'm going to subtract these equations. And when I do, the radicals are going to cancel out, and I'm going to end up with 2x, which is real cool. Because that gets me to x faster. Obviously, we're there, right? X becomes this. Now, why is this different from the first one? Because we can still make a common denominator. Remember, our expression contained e to the power 2y. I mean, you can also multiply the top and the bottom by e to the power y. And when you do multiply by e to the power negative y, it becomes 1. And you get the same result as before. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.